Hey, do you want to learn about black holes? Yes. Yes, you do. Because they're awesome. Let's go. So, what is a black hole? Basically, a time warping star zombie. It's only one of the coolest and most mysterious things in the universe. It all starts with a really big star at the end of its life. A star gets its energy from nuclear fusion, which means that it fuses elements together in its core. As the star lives out its life, the elements it fuses together create heavier and heavier elements. Eventually, the high-mass star will run out of elements it can use for nuclear fusion. With no more fusion happening in the core, the star can't hold itself up anymore, so the star explodes in what is known as a supernova. What's left of the dead star is a small corpse of the core with a very high mass because of all the heavy elements it produced. Sometimes, its mass is so great that it can't hold its own weight, so it's forced to collapse into itself, continually crushing itself out of existence. Behold, a black hole. Why is it called a black hole, you ask? Because a black hole is so compact and has such a strong gravitational force that the escape velocity is faster than the literal speed of light. So not even light can escape it. Yeah, it's crazy. When talking about black holes, we inevitably get into something called space-time, because black holes bend and warp it. Space-time is the four-dimensional combination of space and time. Since we can't really visualize four dimensions, space-time is usually shown like this. Here's the sun. The sun has mass. Because it has mass, here's what it does to space-time. Now here's a black hole, and here's what it does to space-time. The black hole is basically a bottomless pit in space-time. A black hole has this thing called an event horizon. Basically, it's the point of no return. If you went past this point, you're a goner. Speaking of visiting a black hole, the closer you get to it, the stronger the gravity. At one point, gravity would be so strong it would pull your feet, or whatever is closer to the event horizon, much more than your head, essentially stretching you out and squeezing you into a spaghetti noodle. Thus, spaghettification. Seriously, that's what it's called. So yeah, unfortunately, you wouldn't survive to experience whatever is inside the event horizon. But you may just get to see the back of your own head before you're gone. What do you have to thank? The photon sphere. At a certain point, light, or photons, can orbit the black hole, meaning you could theoretically look to one side, and the light reflected from the back of your head would travel around the black hole back to your eyes. That's only the beginning of the craziness. So, earlier you saw how black holes bend space-time. Now we're going to talk about the time part of that. Time is a strange concept. It's not as solid and unchanging as you might think, especially around a black hole. Imagine you have two clocks, or timers. They display the time in blue numbers. If you set the timers to count down from the same number at the exact same time, and then let one be pulled in by the black hole, this is what would happen. The timer going towards the black hole would start to count down slower and slower compared to the one you kept with you. It will also be redshifted, meaning instead of showing blue numbers, they will become more and more red the closer the timer gets to the black hole. At a certain point, the timer will be so redshifted that you would need to see in the infrared to see it. Then, just before it hits the event horizon, it would look as if the timer stops moving completely, and the countdown on it would freeze. Then it would just disappear, never appearing to cross the event horizon. But if you went with the timer into the black hole, nothing on the timer would change. It would stay blue and stay counting at the same rate. Did you know that technically anything can become a black hole? Even you! An object just has to be compressed into a small enough space. Mount Everest, for example, would become a black hole if it was crushed into something smaller than a nanometer. If the entire Earth was compressed to the size of a peanut, it would become a black hole. Another interesting fact is that there is a supermassive black hole, which is millions or billions of times as massive as the Sun, at the center of most large galaxies, including our own, the Milky Way. But even more interesting is that we don't know how these types of black holes form. One idea involves a chain reaction of collisions of stars in compact star clusters that results in the buildup of extremely massive stars, which then collapse to form intermediate mass black holes. The star clusters then sink to the center of the galaxy, where the intermediate mass black holes merge to form a supermassive black hole. So basically super large stars collide, then collapse into a medium-sized black hole, then a bunch of medium-sized black holes collide to make a supermassive black hole. Another idea is that they form from the collapse of massive clouds of gas when a galaxy is forming. Yet another idea suggests that over a long period of time, a black hole will consume a ton of material and eventually grow into a supermassive black hole. Hey, guess what? We actually have a photo of a black hole. I won't keep you in suspense. Here it is. On April 10th, 2019, the Event Horizon Telescope captured an image of the black hole at the center of the galaxy M87. This black hole is 6.5 billion times as massive as the Sun. The Event Horizon Telescope is not just one telescope, but actually 8 different radio telescopes at different places around the globe, all working together as if they were one telescope the size of our entire planet. Have you ever wondered if a black hole could eat up an entire galaxy? As seriously cool as that sounds, to observe at least, no. Even the gravitational pull of supermassive black holes isn't large enough to eat a whole galaxy, which just goes to show you how enormously huge a galaxy is. So, unfortunately, the time for this video to end is here. There are so many more interesting facts and theories related to black holes, aka time-warping star zombies, that we didn't talk about today. If you're interested, just a few topics you could look up are quantum entanglement, a Morris-Thorne wormhole, and an Einstein-Rosen bridge. Very cool stuff. The end.